Hello and welcome back to the course. In this video, I will be talking about the design process, or the steps to take when making a robot that will do a certain task. No matter what that task is, whether it's navigating a maze, shooting targets, or stacking cones, chances are you're going to go through the design process. So what is this design process? In short, the design process is a way to approach and solve a problem. It's a methodical series of steps you can use to get closer and closer to, if not completely achieve, an ideal design for your robot. Here's what the overall flow looks like. Okay, so you may be thinking, what is this enormous rainbow diagram thing on my screen? But don't get overwhelmed. We'll break it down and dive into each step together. The gist of the flow is that you first break down your problem and know what your limitations are. Then create a solution and see if it works, and then redo certain parts if necessary. So let's look at the first step, defining the problem. Defining the problem is describing each of the smaller tasks your robot should achieve in order to achieve the main goal. I'll use VRC's game from a couple years ago, where points could be scored by stacking cones in a corner of a field. This may seem pretty abstract and vague at first, so let's break it down into smaller steps. These could be driving, grabbing a cone, putting it on a stack, and safely transporting the stack to a corner. Later on, though, you might find that you may need to be a bit more specific and break down each of these tasks into smaller subtasks. For example, for putting a cone on a stack, you may need to break it down to grabbing the cone and then lifting it up. Next, we need to do some background research. This could be looking up different mechanical systems, or even learning about robots in general, which is kind of what you're doing right now. You should also be observant, because you might see something that'll give you inspiration or an idea. To build off the previous example, maybe you pass a construction site and see a forklift and realize you can use a similar concept for lifting and transporting a stack of cones. Keep in mind that you shouldn't get stuck here for too long, because you'll be learning things along the way too. So in general, background research is learning a little and keeping an eye out for ideas, which will be used in the next step. Next is specifying the requirements. This is essentially limits that must be placed on your robot. It could be budget, material, size, or something else. If you're competing, this could be a size restraint or how many motors the bot is allowed to have, so this is definitely a good place to start reading the rulebook or game manual. This is also where you determine what qualities your robot needs, such as how fast it needs to be or how much it should weigh. So our cone stacking bot needs to be strong enough to carry a large amount of cones. Basically, this is where you determine what qualities your robot should and should not have. Okay, next is brainstorming. This is where you should think about how you can actually implement your concepts that you got in the background research step. For our cone stacking bot, we said we can make it work like a forklift, but how can we actually put this together with mechanical parts? I highly recommend you make models and diagrams to aid your thinking. They don't even need to be super fancy. Even a quick sketch works, but it should give you and others a basic idea of how the design works. It's important to remember to not limit yourself just yet. Keep every idea that comes up on the table. Once you have as many ideas as you can think of, it's time to evaluate what you've come up with and determine which design you want to pursue. This can be done with a pros and cons list for each design, voting, or any other evaluation system you can find or come up with. You may also find that you need to do this not only for entire designs, but for smaller subsystems or portions of the robot as well. Alright, now that you have an idea, you need to give it a body, which is the prototyping step. This is just creating a simple, basic, and quick working model of the idea you chose so you can test and validate it in the next step. So in the interest of time and simplicity, you may decide to relax some of the limitations you previously defined. At the same time, though, don't put half effort into it. Make sure it's functional so you can test it properly, which is the next step. Keep in mind that if you're just starting off on building your robot, you shouldn't prototype the entire thing right off the bat. For prototyping and testing, take it one subsystem at a time. Okay, so you now have a prototype on your hands. Now you need to know if and how well it works. First, take a moment to recall what your prototype is supposed to do by referring to your task breakdown from the first step. See if your prototyped design is capable of performing most, if not all, the tasks it's designed for. Make sure it can do the primary tasks repeatably. testing once is not enough. It's a good idea to make it repeat the same task several times in a row to see if your structure can hold up. A good idea is to record everything on video so you can go back and pinpoint exactly what went wrong. This also kind of falls into the next step, recording the results. Okay, so maybe your mechanism worked, maybe it didn't. Whatever the case, it's important to keep a log of what you did and what happened. Maybe you want to write quick descriptions of what happened or what you changed, or maybe you want to draw a few quick sketches in a notebook. It's up to you, but make sure you hold on to this log and always update it because it can prove to be extremely useful, since you'll know what worked and what didn't. You don't want to be repeating the same mistake twice. So let's just say, for the sake of argument, that your mechanism didn't work. It's possible that there was something wrong with the way you tested. Maybe you set up the robot's environment wrong, or you forgot to screw in something small. That's why it's always a good idea to retest the same idea multiple times and keep revising your work. It's also possible there was just a subsystem or a certain portion in your design that didn't work. So you should try to pinpoint which subsystem didn't work and rethink that portion, while attempting to keep the overall concept the same. There's also outcomes where it seems nothing works. If more than about 50 to 60% of your mechanism was way off from working properly or being efficient long term, you should probably rethink the design. Now that you know what needs to be fixed or redone, it's time to return to the right step. That could be brainstorming, evaluation, prototyping, or testing. It all depends on your situation. So you'll always find that this is the figurative storyline of any good design. It's the difference between an okay-ish bot and a great bot. Not only will you reap the benefit of the amount of effort and thought you put into your design, you will also learn and discover things you never knew before while doing it. So, in short, don't get discouraged if something fails and keep thinking and learning about what you're doing. And that's all for now. I hope you enjoyed and learned something from this video. I always welcome feedback, so feel free to leave a question or a comment below. Thanks for watching.